Dear students, in this class we are going to see about Introduction to Optical Communication. So the first unit deals with basic laws and that is basic optical laws and its definitions and different optical modes and its configuration, and also we are going to analyze the optical signal through the fibers, and also we are going to see different types of fibers based on refractive index and based on the material and based on the mode of propagation. Basically, we have single mode fiber, graded index fiber, and also at the end of the unit, we are going to see the fabrication techniques. Okay, so waveguide. Optical fiber is nothing but a waveguide. Okay, these are all simple examples for waveguide. An optical fiber is a cylindrical dielectric waveguide capable of conveying electromagnetic waves at optical frequencies. That is, the light signal is propagating in the form of EM wave. Light signal is propagating in the form of EM wave. And we can understand from the diagram. Basically, we can classify the fiber based on the mode. We can classify into two types, that is single mode and multi-mode. Single mode is the one in which only one light path for signal is allowed, whereas multi-mode means there are multiple paths available from one point to another point through the fiber. So first we'll see the fiber structure. So similar to a coaxial cable, here also we have two conductors. One is core, the other one is cladding. One is the inner conductor and the cladding is the outer conductor. So through core only the light will be propagating through the fiber. So refractive index of the core is taken as N1 and refractive index of cladding is taken as N2. So the condition which is required is N1 always greater than N2. That is, refractive index of the core is greater than the refractive index of the cladding. And coming to the basics, we have three types of rays involved in this. So the three different rays are, first one skew rays, second one meridional ray, and third one axial rays. So skew rays are the rays that will never touch the axis of the fiber. They are they will not lie in a single plane. So hence it is very difficult to analyze. Second one, meridional ray. Meridional ray, these are the rays that are passing through the axis of the fiber, and it will lie in the single plane, hence it is easy to track the signal. And then axial rays. Coming to the axial rays, the rays which are passing through the axis of the fiber. These are the three different types of rays. So skew rays does not pass through the center axis, it will take a zigzag path, and meridional rays always cross the fiber axis. Axial ray travels along the axis of the fiber and stays at the axis all the time. And we can classify optical fibers based on material, number of modes and refractive index profile. Based on the material, it is classified into glass fiber and plastic fiber. Based on number of modes, it is classified into single mode fiber and multi-mode fiber. Based on refractive index profile, it is classified into step index fiber and graded index fiber. So the basic two types of index profiles are step index and graded index fiber. So let me see one by one. The fiber basically classified into step index and graded index. Further, it is classified based on the mode as single mode fiber and multi-mode fiber. And in graded index fiber also we have single mode and multi-mode fiber. So the first diagram shows the step index profile and second one shows the graded profile. So step index profile is the one in which the refractive index of the core is uniform throughout the core, and when it encounters the core cladding interface, there is an abrupt change. That's why it's called as step index fiber. Whereas coming to the second one, graded index fiber, here the refractive index is not uniform. Refractive index is not uniform throughout the core of the fiber. Here it will be having maximum value at the center of the axis, and gradually it is decreasing towards the core cladding interface. So if you have varying refractive index, that is called as graded index fiber. If we have uniform refractive index, that is called as step index fiber. So the first diagram shows step index fiber. Here we can see core has a uniform refractive index N1 and cladding has N2. Okay, N1 is always greater than N2. This is the formula for the refractive index profile, that is step index profile. Here we have N1 and N2. N1 is a core refractive index and N2 is a cladding refractive index. So with respect to radial distance R, the core radius is compared, that is R is less than A for core and the radius R is greater than or equal to A for cladding. Total number of modes guided in this case is the step index fibrous. MS stands for number of modes supported by step index fiber, that is equal to V square by 2, where V is the normalized frequency. And also here we can see the index variation is del is equal to N1 minus N2 by N1. Coming to the graded index fiber, here the refractive index is not uniform within the core. It is following a graded index profile. Okay, here the del variation is N1 square minus N2 square divided by 2 N1 square, and the number of modes guided is given by MS equal to V square by 4. And if we compare step index and graded index fiber, based on different parameters we can compare, and data rate step index fiber it is low, whereas in graded index fiber it is higher. Coupling efficiency is higher in the case of step index than the graded index fiber, and ray path based on the ray path, it is following the principle of total internal reflection. Light ray travels in oscillatory fashion. Index variation formula del is given by N1 minus N2 by N1, and here it is N1 square minus N2 square by 2 N1 square. And numerical aperture remains same in the case of step index, whereas in graded index fiber it changes continuously with the distance from the fiber axis. And material used, plastic or glass is preferred, whereas in graded index fiber only glass is preferred. And bandwidth efficiency is from 10 to 20 megahertz, whereas in graded index it is 1 gigahertz per kilometer. So graded index fiber supports greater bandwidth than the step index fiber, and pulse spreading is more in the case of step index, and whereas in graded index fiber it is less. So graded index fibers are preferable. Attenuation is very less in the case of graded index compared to step index fiber, and normally we can prefer light sources like LED or lasers. And application subscriber local network communication and local and wide area networks. That's all for today's session. Thank you, students.